Cologne, this wonderful city. I hope you had a good evening last evening. The weather was kind to us. So it's nice to be back in Cologne. I'm speaking today on safety performance indicators, but the presentation is actually more broad than that. And it is a review of some of the issues that we need to take into consideration for the new advanced air mobility or urban, particular focus on urban mobility. So I want to raise a few issues. I know there are lots of working groups and lots of activity, and many of these subjects are already being discussed by you folks. So I'm not here to teach, I'm just here to highlight a few pertinent issues that I think we need to sort out over the next 5 to 10 years. So, zero accidents must be our target, even though, of course, we never actually achieve it. Aviation is still a relatively young industry, about 113 years of powered flight, but we do achieve a remarkable level of safety, given the complexity, the orders of magnitude of complexity, and now moving from federated systems to integrated systems, of which air mobility is certainly part. The safety record we do achieve is quite remarkable, and it's in everybody's interest, of course, to maintain that level of safety so that the public can have confidence in every type of flight, whether it's rotorcraft or fixed wing or, as I say, the new vehicles, which are a bit of both. So there we go. What I did, because we have no historic data, we have no accumulated data from operational experience for UAM. In that sense, that's the future to come. We have to perhaps look at the past in analogous type operations. And so what I did is I sort of reviewed the last 20 years of sort of major fatal helicopter accidents in the urban environment. And there's some themes that stand out here. Certainly for the first three, and then perhaps the last two have pertinent issues, but are not so generic. Foreseeable risk, of course, most of our certification activities are looking at setting safety objectives and demonstrating that we meet those safety objectives. And that's taking into account those risks that we can foresee. And we know that there's a difference between design safety and operational safety. We accept the fact that we cannot foresee everything. So we need to extend the scope of our analysis as far as we possibly can to the limits of our imagination. The second one points to a case where fatigue, maintenance fatigue in this particular case, but fatigue is not just a flight crew issue, it's an issue currently with all aspects of human participation in the aviation system. People are under pressure, immense economic, financial pressures of the times. We need to be cognizant of all the issues surrounding human activity, human factors, and the part that fatigue plays in that. Now, the third one, in fact, this was an accident that occurred when I first arrived here in Cologne back in 2005, large helicopter accident in Tallinn. And this pointed in the accident investigators' report to a lack of oversight. Now, this is the partnership between the authorities and the industry. The authorities have an important role to highlight and to identify where there are deficiencies in the operating environment and ensure that corrective actions are put in place to overcome those difficulties. And in this case, oversight was a problem. So those first three really are safety management systems related. And a big part of safety management, a big part of SMS, a big part of Annex 19, a big part of safety management, which is now applicable to all domains, whether it's aerodromes, whether it's operations, whether it's air traffic, now also applicable to design and maintenance environments. Those are safety management related issues, and safety management systems are there to try and overcome some of those issues. So the last two are more particular risks. The Glasgow accident, fuel starvation, What do you do when you lose power in a cityscape, a very dense cityscape, unexpectedly, and there's very little opportunity for recovery action? And the last one, see and avoid. There are very few mid-air collision accidents, but they do tend to occur more frequently at low altitudes. This is actually referring to a New York accident. The inherent failings in see and avoid. We know perhaps the first generation of eVTOL will be piloted, perhaps day VFR. It's the first operations that are put in place. We will still be depending to some extent on see and avoid, although we need to overcome that with more integrated systems. So that highlights some of the challenges that are not just the helicopter world to face. The UAM world will have to face them too. So why don't we hit the target of zero accidents? Well, as I say, I've talked about those foreseeable risks that we take into account in our analysis. In initial certification, that is our aim, to try and extend as far as possible our perception of the foreseeable risks and ensure that we take actions either to eliminate the risk, mitigate the risk, or reduce the risk to an acceptable level. Now, in some cases, we have very high utility operations where we're prepared to accept a little bit greater risk, particularly in mountain flying. And of course, human error doesn't obey the probabilistic world, where we depend an awful lot on probabilities and our calculation of probabilities in terms of acceptable designs. But the human factor, of course, is not so amenable to probability numbers. Then we know there is this difference between the design world and the operational world. And of course, there are these unpredictable factors. You know, the 10 to the minus 9 events do occur. To my own experience as a former avionics design surveyor for the UKCA, who was involved in design certification, I know those 10 to the minus 9 events do happen in the real world. So how do we prepare ourselves even for those extremely improbable occurrences? And we need to be in pursuit of new knowledge all the time, because we are entering into a new environment. That was particularly emphasized to me this morning because I took a rather circuitous route to get here. I thought I'd walk through the Rhine Park, forgetting there's a railway line that separates the park and the Messe here. So I had to cross over the motorway bridge. But the motorway bridge gives you a view of the cityscape and all the obstacles in the cityscape. Some of them are permanent buildings like the Dom, and some of them are factory towers which may be demolished. Some of them are communications equipment, towers, cranes everywhere, construction sites. It's a highly dynamic environment, the cityscape. And this presents us for flying with a new set of challenges, and where we need and where we demand new knowledge, and we need to acquire the experience in being able to do that. So those are some of the issues. There we go. What can go wrong? Now, to anyone who's involved in functional hazard assessment, you know, the old 1309 world, will be familiar with looking top-down on the issues, because there are very few things that can cause fatal, catastrophic events. And these are some of them. Most of our focus is always on high-energy impacts. I mean, CFIT, you know, for commercial fixed-wing world is still a major challenge, also for helicopters as well. Obstacles, oil rigs, hitting obstacles on oil rigs is still a significant hazard. Mid-air collisions, as I say, we need to take that one into account. And there's the failures of the equipment itself. Although with some quadcopters, perhaps a blade failure is not so catastrophic as it might be for a conventional helicopter. But the next section, maintaining a habitable environment for the human being, we have some greater problems there, certainly with smoke and fire. You know, if we're going to have, and we've already seen some prototype fires, fires with prototype aircraft, the toxicity of the fumes, the intensity of the fire, there are certainly some very significant challenges and hazards to be taken into account here in your top-level analysis. Now, I'm not going to talk about the one at the bottom there, but we all know cybersecurity is a very hot topic at the moment. the malicious behavior of individuals, particularly where we've got highly integrated network systems with lots of interdependencies, then cybersecurity is as important as safety management systems. So those are some of the reasons perhaps we don't always hit the target, but best practice is employing safety management systems, but not just in the letter, not just in ticking the boxes, but an active safety management system which is looking at the risks of everyday operations every day. That's what's going to keep us as close to the target of zero as we can possibly get. And say, universal SMS, I've mentioned it covers all domains now. It's not just something for the ops world. It's not just something for the ATM world. It's for design and maintenance as well, the 145s and the camos as well. And it's not that complex. I'm always distressed at some of the consultants who make this a little bit overcomplicated. It's to know your risks, to constantly look at them and review them so that you do know those risks, to check, to do something about them, and then, this is what I'm talking about here, safety performance indicators, to actually verify that you're achieving what you set out to achieve. And to do that, you need metrics. You need to measure something. And that's why safety performance indicators are important. And it will be important in AAM, just as important as it is in every other domain of aviation, particularly, I think, in urban environments. So there we are. Constructing those safety performance indicators, oh, well, we can do that. We've got plenty of data. That's no problem. You know, I've had plenty of people assure me, oh, it's easy. Well, actually, you have the opposite problem to what the problem I had when I started in the certification business. I remember the days of flight data recorders when you only had 5 parameters to play around with. You know, you had a real paucity of data. And now we have huge volumes of data. But finding the needle in the haystack is sometimes just as much a problem as not having enough data in the first place. So the construction of those indicators, what you choose to look at, is vitally important. And that's what the presentation is about. You're going to need a new generation of safety managers. You know, if we start going into operational service 2025 or something, you know, day VFR, piloted operations, in urban environments for very sort of controlled routes. You're going to have a whole operational organization, and of course there'll be a safety manager within that operation. Their job will be to maintain safety management systems, but also to point out to their management what corrective actions we should be taking, what knowledge do we need, what kind are the indicators telling me. Now, if we're going to have a dashboard that says green every day, that's no good to anyone. You can have, it's a voyage, a safety manager's job is a voyage of discovery. Every day it's a voyage of discovery, finding something new. And with a system of systems, a highly integrated system, that means working in new ways. It's not aviation working in isolation. That manager is going to have to work with the city planning offices. They're going to have to know where those obstacles are, what's moving around, what the expectations are in terms of the weather, in the micro weather in the city, what the expectations are in terms of dynamic objects and things moving around. So the level of coordination and collaborative activity is heightened. And it's also the case that we're going to see these horizontal organizations where the manufacturer of the vehicle may also be operating the vehicle in cooperation perhaps with a city authority that might have no familiarity with aviation. So there are all those new challenges for that safety management system to take on board. What are the building blocks for performance indicators? Here are some of the standard ones. There's nothing unique or special about UAM here. You know, there will be occurrence data. There will be a requirement for mandatory occurrence reporting. Hopefully we'll have operational flight data monitoring where you have volumes of data collected from operations, probably stored in the cloud, more data than you can know what to do with. You may be mining that data with expert systems. But you're still going to need the skills of the human analyst to be able to extract intelligence from that data. The authority is going to audit you every so often, so you're going to have your internal audit data and external audit data. But what I'm looking at here, and the point I wanted to raise, is it's no good each individual manufacturer doing this in isolation. It's no good each individual city doing this in isolation. It's no good each national authority doing this in isolation. The real benefits will come as we learn together in introducing these new aviation systems. So there is going to be a need for collaborative working, for sharing data between organizations. Organizations today, which are in a highly competitive environment, where intellectual property is extremely sensitive and extremely valuable. So how are we going to learn to share safety and performance data between organizations for safety's sake? Now, it's often said that we do not compete on safety. Now, those are easy words to say, but they are rather more difficult to do in the real commercial world. Data pyramid in terms of value, let's say we have this enormous amount of raw, unstructured data in an extensive integrated system. Some of it airborne-based, some of it ground-based. The data is there. Somehow that's going to have to transformed or reduced into the contextual information, the information you need to run the operation. Not everybody needs to see everything. It needs to be streamed for different customers, for different decision-making processes. And somewhere at the top of that, the CEO is going to have some indication of what the big problems are with safety of operations. Safety management systems means safety culture. Your CEO has to know really what the key safety issues or challenges that the organization is dealing with, and that's the wisdom and knowledge at the top of the tree, which can ensure that decisions are made to take corrective actions in a timely manner. Now, this here is the cost. None of this is free. It might sound like it's free, but even if you apply a level of automation on the data with expert systems, you still have to train those systems. The expertise has to come from somewhere. So the trained analyst still has an important role to play in this. And it will be a highly dynamic and variable environment as we learn as we go, as you extend the capability of operations. So it's not a static environment either. So resources need to be dedicated to that kind of work. And that's one of the messages I'm trying to get out today. This is not for free. Someone has to do it. But some of the data will have a monetary value. Now, I'm thinking particularly of weather data, the micro-weathers within cities, winds, the wind patterns within cities. The UAM world is going to be very interested in that, but so are the meteorological people, and so are the city authorities. And people will be prepared to pay for that data. So whether you can fund your safety work and your safety analysis work in that way, but some of the data will be able to be monetized. But this sharing and getting over the difficulty of the sensitive intellectual property, I think, is a really big challenge for the industry currently. Performance indicators, many different types. Let's say the numerator's easy, that's the subject we're looking at. The denominator's not so easy, and I've seen these debates go on in a number of research groups in NASA. Well, per flight hour is fine. Commercial, that's what we use, for 1309 for design analysis. But actually, this may require a different denominator. I mean, particularly if we have vehicles at transition, so numbers of transitions, numbers of occurrences of problems related to the number of transitions. You may need to construct indicators with different denominators. It's more complex than just counting things. And the nice thing about rates is you can also then draw comparisons, and you can have a datum, and you can say we're above a metric or below a metric, an industry standard metric. You can see how well you're doing. So this requires some intelligence, some thinking. So effective indicators, you need that exposure data. You need to collect the exposure data as much as you need to collect the actual occurrence data. You need to construct those indicators in a timely manner. And do we need to harmonize them across the industries? Yeah, if we're going to have UAM operations in Singapore, in Los Angeles, in London, in Cologne, we're going to have lots of different people working in this area. Is there a significant requirement here for some kind of industry harmonization of the safety metrics that we use to judge and to demonstrate to the traveling public that we have a safe industry? Now, there are different schemes of indicators and different structures that you can put in place. This is one that's often used as sort of 3 tiers, where you have the tier 1 is the very significant big event. Tier 2 is the more particular factor that you're looking at. Here, say, looking at landing excursions at a vertiport. And you may have leading indicators and lagging indicators. Most of what I've talked about here is lagging indicators. It's evidence from the history books. You know, it's the collection of data from today's operation and yesterday's operation. But we also have this construct of leading indicators, where, say, we're putting a modification to a flight control system in place, but we've only got half the aircraft equipped. We're actually tracking the indicator of equipage. You know, how quickly are we introducing this safety improvement? That's a leading indicator, tracking that kind of, is it having the effect that we expect? So you have to track both leading and lagging indicators. Right, there we go. And for complex, highly integrated systems, there are other things too. The military folk are very keen to look at no-fault founds. In the maintenance environments, it's a avionics world. It's a horror. Pulling boxes and changing things, and you can't work out what happened. You don't have the time to do the investigation, so you have to put it down as a no fault found. For systems of systems and highly integrated systems, we've got to do better than that. We really have to dig deep into some of these no fault founds, and we have to track them. And that's the safety indicator I think that we will need to pay attention to. The other one, important one here, comes from my experience of HUMS, helicopter health and usage monitoring systems. Sensor errors. If you've got accelerometers and things like that. The calibration of sensors, very important, because if you put garbage into your data system, you will get garbage out. So ensuring that the integrity of the data that you're actually using for the analysis purpose is as important as the analysis itself. Otherwise, garbage in, garbage out. There are different customers. I've already mentioned that. This is not just operational and safety management within the industry. It's also demonstrating to the public that we have a safe system and third parties. And policy, future policy will be made on the basis of industry statistics and authority statistics, you know. These indicators, you know, being able to demonstrate, to show people that your safety performance is a good performance against a baseline is absolutely critical in moving forward. So that's briefly what my presentation was about today. Universality of SMS. Well, that's happening anyway, and Annex 13 is a good toolbox. Annex 19 is a good toolbox. The new type of safety manager who's going to have to work across transportation systems, perhaps, maybe learn some things from our rail folk, you know, and the highways folk. You know, aviation folk in a city environment are going to have to start talking to planning departments. And other modes of transportation. So it's an interesting opportunity there. The challenges of intellectual property and confidentiality, how do we get over sharing? How do we bring the industry together to be able to share this data? And we need that cooperative data sharing, and I think it should be industry-led. And safety, it's not the CAO's statement, it's an ongoing activity. And thank you very much. That's my slides for today and my message for today. And I'm John Vincent from the International Federation of Airworthiness, and a former, spent 11 happy years here in Cologne with EASA, and before that with the UK Civil Aviation Authority working on aircraft avionics. So thank you very much, and if there's, well, I think I've run out of time. Is there any time for questions? No, there's no time for questions, but I'm happy to talk to anyone around the show a little bit later on. So thank you very much, ladies and gentlemen.